Good morning, guys. Go ahead and let me know who's here in the chat so I have an idea what's going on. Three people, nice. Morning, Rachel. Good to see you. Morning, Liberty. All right, so we got two people. I'm guessing Hunter's probably going to be in and out because it was three for a second, so maybe Hunter's here. Give it a second, see if he pops back in. How's everyone doing? You guys having a good morning so far? There's Hunter. Good to see you. I realize that I have a lot of stuff due today. Yeah, it's a tough realization. This class, though, not going to have much going on, so that's good. All you're going to have, we're mixing it up today. I know it's been a while because most of the stuff that we've done has been review and just maybe like quick little notes here and there, but today we're actually going to be learning a new topic. So if you guys look at your calendar, you can check that out, but we are learning a brand new topic you haven't learned yet. That is a BC topic. So that'll be good. Nice little change of pace today. I'll be talking and then lecturing a little more than you guys doing work, but so yeah, that's what we're going to do today, and then you'll just have a Khan Academy assignment for homework, so not too much work from this class. So maybe that'll ease your mind a little bit, Rachel. All right, well, to start, guys, I would like to go over the progress check. So FRQ Part B, Unit 6. So I'll give you guys the answers, and then you can let me know if you want to go over anything. So get that out, and then in the chat, maybe just give me a thumbs up, okay, if you guys are good, ready to review the FRQ, so I can start. So I found a Netflix show yesterday. It's really popular. It's like the #1 show on Netflix, I think, right now. And I guess it's not really a show. It's more a documentary. But it's called Tiger King. I don't know if you guys have heard of that. It is wild. Let me tell you. Wild. I just started watching it yesterday, so I'm not too far into it. But it's I couldn't believe how crazy it was. But anyways, it talked about, I don't know if you guys remember this. I faintly remember it. But there was a case in Ohio. I can't remember the exact place it was at. But there was a guy who had all these like exotic animals. So he had like, I think it was bears, lions, tigers, like all these different exotic animals. And this was in Ohio. And he released them like in the public. So he was taking care of them and no one knew. He had this wild animal enclosure. And he's taking care of them. And then he let them go. I don't know why. I think the guy just went crazy and he let them go. And they were just like roaming around Ohio. Like this town in Ohio, they were just like these wild animals. Like someone called the police and was just like, "Hey, there's a tiger in my backyard," and then they were just roaming around the place. Crazy. I faintly remember that, but it's insane that it was in Ohio. Just imagine like in Vermilion, just like a horde of wild animals being like, "Oh, crazy." Anyways, if you guys have nothing to do and you're bored, and you want something to watch, recommend it. Tiger King. All right. So, looks like maybe we'll be all right to review. All right, thank you, Hunter. Yeah, but the documentary, it mentions that Ohio thing, and I thought that was funny. But it's about this like these other big cat enclosures, basically, which is just a wild like I guess lifestyle to live. It's craziness. Okay, so you guys look like you're ready. I'm gonna get started. So, FRQ Part B, number one. Well, there only is one question. So 1A, you should have gotten 53 over 4, or any sort of decimal. I don't think you had no calculator, so you couldn't have gotten a decimal. I doubt. But 53 over 4 should have been your answer for that, or some form of that, or 13 and 1/4 maybe, however you had it. Part B, you should have gotten 11 over 3. Again, Part B, you should have gotten 11 over 3. Part C, you should have gotten 4. Again, Part C, you should have gotten 4. Part B, you should have gotten 11 thirds minus the natural log of 12 divided by 3. Again, 11 thirds minus natural log of 12 divided by 3. Or maybe 11 minus natural log of 12 all divided by 3, however you decided to write it. All right, so go ahead in the chat, guys. Let me know if there's anything you want to go over for that, or if you guys are good. I'm going to blow my nose real quick. All good. Good for me. Yes. Okay. Perfect. Then we are set to go. So guys, in your calendar, you can see today we're going to do notes on Euler's method. Now, that's how I always am going to accidentally say it. It's actually pronounced Euler's. So it doesn't look like that at all. But it's one of those things that like people who are really heavily invested in math, if you say Euler, you're going to hear about it. So Euler. We have a hospital and Euler. So it's not like Ferris Bueller, it's Euler. So that's what we're going to learn about. We're going to learn about Euler's method. Okay, and I'm going to switch cameras here so you can see. So you can just title your notes Euler's method. Again, this is a new BC topic for you guys. I can't imagine you hit on it in AB, but I guess I don't really know. Okay, so Euler's method. That's the concept today. Now, big thing with Euler's method, it's very, very, very similar to linear approximation. So if you guys remember, I don't know how many units ago, maybe 2 or 3 units ago, we talked about linear approximation. I mean, you guys have learned it before, but we did like assignments on linear approximation, which is just basically a way we could approximate values of functions. And we did that by taking tangent lines like very close to that point. So with linear approximation, we would take like f of a or whatever plus f prime of a plus or times f prime of x minus a. So we had those different combinations for linear approximations, and this is going to be very, very similar idea. Okay, so Euler's method is going to use that concept, except it's applying it to differential equations. So that's the big difference. Is with Euler's method, we're going to be using this for approximating differential equations. Big word, approximating, just like a linear approximation, right? Obviously, it's an approximation. Same idea for Euler's method. We're using it as a good way to get an approximation of our values for differential equations, our solutions to differential equations. And if you guys remember, for differential equations, to get the solutions, idea is to get a function value. So just as a refresher of differential equations, so I guess I forgot we haven't even started Unit 7 yet, review yet. So just so you guys know, Unit 7 is going to cover differential equations. All right, so everything we're doing in this unit will be over that topic. Differential equation, if you guys remember, is just an equation that has derivatives of f, and we're looking to find f. So that's some sort of combination of the original function and its derivatives, basically is what we're looking at. So you might have something like f prime of x plus y equals f of x, or sorry, equals like x or something like that. Any sort of combination, any sort of equation that's a combination of y primes, y double primes, y's, x's, that kind of sort of thing. Differential, big word, is differential. So differentiability, we think derivatives. So that's kind of your hint of a differential equation has derivatives in it. If we're looking for the original function and we're given derivatives, we should be thinking integrals. So we're reversing that process of taking a derivative, you take the integral, or the antiderivative. So that's the idea of differential equations, is reversing that process to get back to the original function. Rather than keep taking derivatives to get farther along in derivatives, we're reversing it. Okay, so what Euler's method is going to do, put it right there, Euler's method is going to use small tangent lines over a short distance to approximate a solution to a differential equation. That's the basics of Euler's method. It's a way we can use a bunch of like small intervals of tangent lines, excuse me, and we can use those small intervals to approximate a tangent line at a point that we can't just evaluate. So, that point might be 1.2, 1.3, something like that, where it's just not realistic for us to get a precise evaluation. So we can use this method to do that. Okay, and to get more details, at the end of the day, Euler's method, the questions you guys are going to be asked on Euler's method is going to be very straightforward. So similar to linear approximation, the way it's formatted is pretty obvious. So the exact same way for Euler's method, it's pretty obvious, being because they literally say use Euler's method. So if it never tells you to use Euler's method, you have an idea, probably don't need to use it. So any sort of mention of Euler's method, this is going to be the strategy you want to use. It may say something like approximation, So I might say approximate this differential equation. Another pretty good hint, use Euler's method. So if you guys want any more like background knowledge of how Euler's method was kind of created and going about, there's a lot of different options you can look online for. So Khan Academy has a video on it. There's a lot of other ones you can look at. For our sake, so we can keep moving at our pace and towards the AP test, I'm going to just go into some actual problems involving it. Before we can do that, though, we need the formula. So this is the formula for Euler's method. Okay, so Euler's method is y sub k plus 1 is equal to y sub k plus f of x sub k, y sub k, times the change in x. Alright, so y sub k plus 1 equals y sub k plus f of x sub k, y sub k, times the change of x. Okay, and a big term we use for Euler's method is called a step. So we talk about steps in Euler's method. Reason being is because, again, the whole point of this method is to take small tangent lines over a short distance. So we're going to take a bunch of different tangent lines. Now, if you notice something very specific about this formula is it's reliant, the value we're looking for is completely reliant on the value previous to it. So the step before it. You can't find y sub k plus 1 without y sub k and x sub k. So you need to get points, and you need to find points and move like in an orderly fashion through the problems. Okay, and I'll show exactly what I mean, but big thing with this step is the change in x is what we call our step size. So that dictates all of our x values is the step size. So let's say we're given our initial value is x equals 0, and our step size is 2. Okay, well then our next x value, x sub 1, would be 2. X sub 2 would be 4. X sub 3 would be 6, and so on. Because we're stepping by 2 every single time. Every single time we move a k, we step by 2. So we call that a step size. Okay, the next piece you see in there is y sub k. Y sub k is the value that's the approximation for f of x sub k. So kind of like what I said, you guys will see in these problems, we're going to be able to find x easily. So every x value, x sub 1, x sub 2, x sub 3, that's all going to be easy for us to find. Because it's all going to be based off the initial conditions that were given to us, and then the step size that will also be given to us. So we'll know what the step size is based off of that. We can find all of our x sub k's. To find our y sub k's, you need to actually evaluate f of x sub k. So if x sub k is 2, you just find f of 2. That would give you y of that. Okay, again, we'll go over some problems, but that's going to be, we're going to find y sub k by using whatever our x value is and plugging into a function that's given to us. Or our equation, I should say, that's given to us. Okay, and then the next kind of unknown factor here is going to be y sub k plus 1, which is just the next step after y sub k. So again, we use that word step. Y sub k plus 1 is the step after y sub k. We use this variable k to represent it because we just don't know how many steps there's going to be. Some problems might make you do 5. Some problems might say 2. Some problems, might say 10. We're not going to get to any problems that say 10, but you don't really know what that subscript is. And then the last little thing, and I probably maybe should have led with this, but k is the number of steps. So you see all these have subs. sub k, sub k, sub k. All that's representing just the number of steps. So if you're looking for if you have a step size of 2 and you want to take 3 steps, then you want to look for y sub 3. That would be ultimately what you're looking for. Okay, it's pretty much your crash course, your introduction to Euler's method here. So I think the next best thing to do then is to actually solve a problem. So let's actually go through a problem and solve it. So I'm actually going to, you guys should be good with the notes probably if you were writing it as I went. So I'm going to flip this page. Just so I can have a fresh page to work on. And this is going to be your first example. Sorry about that. 2 minus e to the negative 4x. And y of 0 equals 1. Let's focus in here. Alright, so y prime plus 2y equals 2 minus e to the negative 4x. And your initial condition is y of 0 equals 1. The question is to use Euler's method with a step size of 0.1 to approximate y of 0.3. Use Euler's method with the step size of 0.1 to approximate y of 0.3. Okay, so this is the problem. Let me get a drink of water real quick. So, a couple things we need. So we have that formula, right? So we want to obviously use that formula, but first let's just put down what we know. So let's put down some information that we know. Right off the bat, we know our step size. So our change in x is going to be 0.1. That's given to us in the problem. Change of x is 0.1. We also know what x sub 0 is. So at step 0, also known as my initial value, I know what that is. So x sub 0, my initial x value is 0. Basically, whatever is given to you is going to be your initial x value. So I'm given y of 0 equals 1. My initial value then is 0. And my initial y value is 1. Okay, so again, all that stuff is given to us. It's all given to us. Okay, now what we want to do is we want to create an equation that's going to give us y prime. So that's a first step, is we want to work with this because we don't have any derivative, because we don't have the original function. So what we want to do is we want to write y prime is equal to, let's write it as 2 minus e to the negative 4x minus 2y. So we're solving for y prime. Okay, so that's an important step in these equations. A lot of times it might just be given to you. So in this type of problem, it'll just give you what y prime is equal to. But the reason this is important is because we need to use this formula. So this formula here needs to be used in conjunction with our previous values to find the next step. So if you guys notice on the formula it says f of x sub k, y sub k. Well, this gives you f of x sub k, y sub k. So plugging in x and y into this equation will give us the next steps. All right, so let's take a look then at our steps. So first of all, we can kind of look right now. If we start at 0, this is my initial value, x sub 0, 0. I have to get to 0.3 with step sizes of 0.1. How many steps do you think we need? Well, 0.1 plus 0.1 is 0.2 plus 0.1 is 0.3. So we need at least 3 steps to get to where we need to go. All right, so we got to start then with step 1. So x sub 1. So my first step, 0.1. So it's all it is 0 plus 0.1 gives me 0.1. Now the tricky part is finding y sub 1. So y sub 1 is found by using our formula for y sub k plus 1. All right, so this is going to be using your formula. You need to find y of k. Okay, well, if y sub 1, if this is equal to y sub k plus 1, then that means y sub k, which goes right here in our formula, should be y sub 0. So 1. So you're just taking y sub 0. If this is y1, that'd be y0, which we know what it is. We found that. So we got 1 plus, using my formula, it's f of x sub k, y sub k. So it's f of 0, comma 1. And then all times the step size, which is going to be the same for every single one of these problems, right, which is going to be 0.1. All right, and to simplify this, it's going to be y, or 1 plus f of 0, 1. Again, we're using this red equation to find f of 0, 1. So we just take f or y prime, and anywhere we see an x, we plug in a 0. Anywhere we see a y, we plug in 1. So 2 minus e to the 0 is what it ends up being, minus 2, all times 0.1. All right, and then calculating this, you can use your calculator for this problem. Not all of them you can, but most of them will be easy enough where you don't need to use a calculator. You know, for College Board especially, obviously. If it's a problem that doesn't let you use your calculator, it's going to be easy enough answers to get. This one's a little more complex, so you can use your calculator. I have faith you guys can use your calculators correctly. So if you were to use your calculator, actually this one you don't need to, but for the other steps you might. You end up getting y prime or y sub 1 is equal to 0.9. So that's my first step. So that's my approximation for y of 0.1. But obviously, we're not looking for y of 0.1. We're looking for y of 0.3. So we have to do this process a couple more times. All right, so, whoops. Now we go to x sub 2. Well, x sub 2 is going to be equal to 0.1 plus 1. That's our step size. So x sub 2 is going to be 0.2. Okay, finding y sub 2, we take y sub 1, which we found was 0.9, plus f of 0.1, comma 0.9. times 0.1. So again, using our equation, 0.9 that's not the word I'm looking for. We got 0.9 from finding what y1 was, or y of k minus 1. So 0.9 goes there. F of xk, well, xk before was 0.1, and 0.9 was yk. And then our step size stays the same, like I said. It's always going to be 0.1. So y sub 2 is equal to 0.9 plus, and then parentheses, 2 minus e to the negative 4 times 0.1 minus 2 times 0.9 times 0.1. Again, just plugging into that red equation, my 0.1 and 0.9. Guess you don't need to box these, but it might help you in your process if you box them and you can know which ones to look at. As a reminder, guys, if you ever have questions as I'm going, just put stuff in the chat. I have it open so I can read what you're putting. So if you're ever curious or have questions on anything and stop me, please feel free. Because if I don't see it, I'll just keep going. Okay, and then the very last step is x sub 3. So now that's what we're looking for. We're looking for f of, or I should say y of, because the question asks y of 0.3. All right, so that's what we're ultimately looking for. And so we do the same process. We take my y2 plus f of x2 comma y2 all times 0.1. So y3 equals 0.853 plus 2 minus e to the negative 4 times 0.2 minus 2 times 0.853 times 0.1. And again, calculators, wonderful tools. You get y sub 3 equals 0.837. And that's your final answer. All right, so go ahead, guys, in the chat. Let me know if you're good, if you feel good about that. If you have any questions, if it makes no sense, perfect sense, whatever. Any feedback you can give me. Makes sense? All right, perfect. Thank you, Liberty. Makes sense so far? Yep. Okay, cool. All right, so let me give you guys a problem you can try on your own. And then we can go over it as a class. So we're going to, this is example 2, use Euler's method. With a step size of 0.25 to estimate y of 1 if y prime is equal to 3y minus 1, and y of 0 equals 1. So use the Euler's method with a step size of 0.25 to estimate y of 1 if y prime equals 3y minus 1 and y of 0 equals 1. So you guys are going to want your calculators out because you're going to get some weird decimals. And I'll give you like, I don't know, however long you need really to do this problem. And then when you guys are done, type in the chat your answer. Liberty said backslash bracket. Weird answer, Liberty. Got that pretty quick though. My notebook was resting on my computer. That's funny. Rachel, you're right. Good job. If you did it right, not sure, but you got the answer right. Yay. Who cares how you got it right? You got the answer right. That's all that matters. Hunter, same answer? Very good. Just waiting to see Liberty got, and then we are good to move on. That's not what I got. Okay. I will go over this. Let me finish chewing. I'm sorry. I'm eating breakfast right now. Okay, so this was the first step. Couple big things. Step size was 0.25. So they give that to us in the problem. Our initial conditions are x of 0 equals 0, y sub 0 equals 1. So that everything in the black there is given to us. To find the first step, you just add x sub 0 plus your step size. So 0 plus 0.25 is 0.25. To find y sub 1, use our formula. So we use y sub 0, which is 1, plus 3 times y sub 0, so 3 times 1 minus 1, just using this equation that was given to us. And then all times the change in x, or the step size. So all times 0.25. Use your calculator. This one's pretty easy, right? You can get 1.5. So the thing that kind of stinks about these problems is if you miss a step, then you are going to be your problem's your toast, right? If you screw something up in one of the steps. So you gotta be very careful with the calculations. Moving on, we get x sub 2 equals 0.5. So again, moving the next step, you add another 0.25 to get 0.5. Y sub 2 is going to be equal to y sub 1 plus f of x sub 1, y sub 1. So it's going to be 3 times 1.5 minus 1, all times 0.25. Liberty said I did that part right. Okay, good. So you're doing good so far. Sorry, this should be a 1.5. My handwriting is very atrocious there. Okay, so again, using your calculator, you're going to get y sub 2 is equal to 2.375. So now I got my new x and y sub k's to use for the next step. And then this process is going to continue. So x sub 3 equals 0.75. Y sub 3 is going to be equal to 2.375 plus 3 times 2.375 minus 1, all times 0.25. Oh, I see what I did. I'm good now. Okay, cool, Liberty. Just so you guys know, then you're going to get 3.906. Whoops. And then y sub 4, same idea. You get 6.586. So it sounds like everyone else got that, and I didn't want to do that last step. I don't know if I don't have to, so. All right, very good. So go ahead in the chat, guys. You let me know. Do you want to do one more practice problem, or are you guys good? Do you want to just start in your Khan Academy? What would benefit you most? There's no other weird problems to these. There's nothing weird to do. No other like way to look at it, I guess. That like what you see is what you get. These are the types of problems you're gonna get. Ray just said, I think I'm good. Right to Khan else. Okay, cool guys. So yeah, go ahead and start your Khan Academy. You don't have to be here to do it. If you guys want to just, you guys want to log off or do something, you don't have to do it right now. But if you would like to start it now while I'm here to answer questions, absolutely feel free. Are you going to add a spot in the Google Classroom for us to make our FRQs from yesterday? Oh, no, Rachel, you're good. Just based off of the fact I think we're all good on it anyways. I don't need to see your work. I trust you guys, so you're okay with that one. No problem, Rachel. Have a great rest of your day. You too, man. Morning, Drake. I'm definitely staying hydrated. You got that right. I'm staying hydrated. I'm actually eating breakfast right now, currently. Probably should have done this before the stream, but I'm eating breakfast, which just is revolutionary for me. It doesn't happen very often. You too, Liberty. Thank you. So I'm pretty proud of myself right now. Trying to keep my nutrition up, you know. Now's the time to get your immune system, get everything right. So I'm trying to stay on top of that. Andrew Massey, good morning. Yeah, you too, Hunter. I appreciate it. Have a great day. Tell Cole he missed a great time, so he feels bad about missing. I'm about to make myself a bowl of oatmeal. Good call. Oatmeal's good for you. That's a nice nutritious breakfast. I don't really like oatmeal. Like if I were to eat oatmeal, and if I had to eat oatmeal, I would just like put hot sauce in it or something. It's way too bland for me. It's boring too. That's just my opinion though. A lot of people love oatmeal. I like that I made this. Calculus AB starts at 10. I need like music to put on. Every time Calculus AB starts, just music starts playing. Good morning, Haber. Good morning, Jasmine. Good morning, Alexis. Guys, while we're waiting for everyone else to come on in, just make sure to go smash the like. Just really smash that like. Feel free to comment, subscribe, the good stuff. But really, I'd like to see those like numbers go up. My BC class neglects it quite a bit. Also, you know, as usual, detentions if you dislike. So don't do that. I don't want to send you to Mr. Brickner. Good morning, Braden. Good morning, Alexis. 1 continued. Morning there, Jonah. Top of the morning to you. Again, if you're just joining us, guys, part of the price to admission for this stream is to like it. If I see those numbers stay down, you have to be forced to block some people from the stream. You understand, it's really a business decision I have to make. Without the likes, pretty much useless, so got to make sure, you guys are participating properly. Just want to throw that out there. I don't know who that is, Drake, but that's me. Let me see if I'm saying this. Jack Septic Eye. That means something. That sounds like a medical condition. Maybe I don't want to know. Maybe I shouldn't. I don't know. Is that an appropriate thing to even say? Maybe I'm not even. Probably shouldn't even be saying that. I'm not sure. But yeah, that's me, Drake. He's my influence really in everything I do. So I kind of aspire to do my stream just like as if he would to do it. Brandon, hello. He's a YouTube gamer. Hey, be nice to Drake. This is safe space, Peyton. But yeah, I'm not a gamer, but I can definitely, those guys are successful, very successful. Top of the morning to you. My name is that his quote? All right. Thank you, Peyton, for obliging. Obliging? Is that a word? Obliging? I think it's a word. Yeah. Thank you for obliging by my rules. I've yet to mute anyone, and I've really been wanting to. So please do not tempt me. Indeed. That's funny. Hey, Drake, by the way, are those assignments all up to date for you? Did you double check? Because I got your email. Here's your notes for today, by the way, guys. This is what we're doing. Verifying solutions to differential equations. Abiding. Was that the word I was looking for, Brandon? You'd be good at, Yes, sir. Okay, Drake, perfect. Abiding. Obliging? Isn't obliging a word? Let me write it out. Obliging. That's a word, right? Oblige. Yeah, it's got to be. Yeah. Okay. Just wanted some reassurance on that. I felt like I was saying that right. Yeah. Okay. Thank you. Man, you guys were making me feel stupid. All right. So guys, today, what the plan is we actually had a lot of time to. Well, so actually, my calendar's incorrect. We're not going to review that because we haven't learned it yet. Oh no. I deleted everything. Back up. Okay. Yeah, we're not reviewing any homework. The right differential equations, how was that for you guys? Maybe in the chat, let me get some feedback. Do we really do a good job writing those differential equations? Were we lost? Nice part with that assignment was it really didn't require any work. It was more just looking at words, reading words, and then creating an equation. So you didn't have too much work you had to do, which is kind of nice, but still some of them could get a little bit confusing, I guess. So I was all right. Thumbs up from Haber. Good. It was good. All right, cool. All right. Well, if you guys did have any questions, I think it's still, I don't think it's due till 3:30ish. So you guys have some time. If you didn't do it, you can still do it. You can come to my office hour later today if you want. If you guys have some questions on it. So today the topic is verifying solutions to differential equations. So we're the process of this unit. All right. So we started off by just introducing what a differential equation is. We talked about with word problems, how can we create our own differential equation? All right, now we're moving into verifying differential equations, meaning we're given the solution. Is it actually a solution? Is basically what's happening. So we're given a solution to a differential equation, and we're given a differential equation. How can we check to see if it actually is a true solution? That's what we're doing next. After this, we're going to be actually solving differential equations. And we're going to be solving differential equations with initial conditions. So we're going to start by just doing a generic solve. So just like we would take a generic derivative or a generic integral, we're going to take a generic, we're going to solve a generic, differential equation. And then we are going to ease into then solving differential equations that actually have specific values. So we'll get actual answers. And then after that, we're going to get into something called slope fields. Very confusing to start, kind of fun as once you figure out what's going on, I guess, that's my description of it. So it's like really just a strange thing just when you first see it, but once we start practicing with them, I think you guys will actually kind of enjoy them a little bit. So we're going to get into slope fields, and then there's one more. Let me see what's the last one I'm missing here. I think there's one more topic. Oh yeah, exponential models with differential equations. Exponential models with differential equations is you guys have used it or exponential equations. So you think PERT. I'm sure you guys have seen that before. P times e to the RT. It's that idea. Just using that formula for differential equations, basically. So that'll be the very last topic of Calculus AB for you guys. And then we are done with AB. Only thing left to do for us will be review for the AP test. So give your guys a round of applause. Do one of these. You're almost there. The finish line is 100 feet from you. You still got some left in the tank, so you're ready to make that sprint. That's the mindset we want to have. All right, make that sprint to the finish line. That is called the AP test. Anyways, I think that's all I wanted to cover in general. So we're going to start today by verifying solutions to a differential equation. So everyone, you should already have your notes out. Oops, I need to switch this to my hover cam. You should already have your notes out. 3/25 is the date. I'm going to start talking. If you guys have any questions as I go, please, in the chat, say, be nice about it, but just basically say, hey, Mr. Harris, stop talking. I need help. Can you chill for a second? So I know. Or I'll just keep going for hours. All right. So here's what I want us to do. In your books, so get your trusty old books out. We're going to go to page 605. So this is where we're going to be at the bottom of 605 where it says general differential equations. All right, so I want to give you guys a little bit of background information on what we're doing. Some of this stuff I've already talked about. I talked about the other day. But this will just kind of give us a little introduction to what we're doing today. So in general, a differential equation is an equation that contains an unknown function and one or more of its derivatives. The order of a differential equation is the order of the highest derivative that occurs in the equation. So you guys think like the order of a polynomial, or the power of a polynomial, or the degree of a polynomial. It's always the highest degree. Same idea here. The order of a differential equation is the highest derivative. Thus, equations 1 and 2 are first-order equations, and equation 3 is a second-order equation. So when we say first order, second order, third order, it's all based off the derivative. First order is a first derivative, second order is a second derivative, third order is a third derivative, so on and so forth. So in all three of those equations, the independent variable is called t and represents time. But in general, the independent variable doesn't have to represent time. For example, when we consider the differential equation y prime equals x times y, it is understood that y is an unknown function of x. A function f is called a solution of a differential equation if the equation is satisfied when y equals f of x, and its derivatives are substituted into the equation. So again, a function f is called a solution of a differential equation. So if our solutions are going to be a function value. So if our function value, f, satisfies when we plug it back into y equals f of x, and its derivatives are substituted into that equation as well. If that ends up being true, if you get a true statement, then you know you're good. Thus, f is a solution of equation 4, which equation 4 they give you guys, the one that they just talked about. So this is equation 4 right here, y prime equals xy. A solution to that is f prime of x equals x times f of x for all values of x. When we are asked to solve a differential equation, we are expected to find all possible solutions of the equation. We have already solved some particularly simple differential equations, namely those of the form y prime equals f of x. For instance, we know that the general solution of a differential equation y prime equals x cubed is given by y equals x to the fourth divided by 4 plus c. So if you guys look down here, like what I just read, we know that's a general solution. Why do we know it's a general solution? So just think to yourselves, why is that a general solution? Or how do we get there? Okay, well, hopefully you guys are thinking about, it looks like they took an antiderivative. And that's exactly what you do. If you have a derivative, in other words, if you have y prime, if we want to get back to y, we take an antiderivative, or we take the integral. So the integral of x cubed gives me 1/4 x to the fourth plus c. So we've already done that. We know how to do that. That's one way to go about it. It's not always going to be that easy, but that's one way to find a general solution to a differential equation. In the last paragraph, but in general, solving a differential equation is not an easy matter. There is no systematic technique that enables us to solve all differential equations. So that's really important to note. We don't have like a cookie cutter way to do it. So for example, we have a cookie cutter way to solve integrals that have composite function times another function. Okay, that's u substitution. We have cookie cutter ways to take certain derivatives, certain antiderivatives, all this stuff. We don't have that for differential equations. There's no rule. There's no like one way to do it. Okay, we're going to learn a strategy that we can use. I guess we're going to learn a couple strategies really of what we can use on how we can get these solutions. But I'm not going to give you a formula and you're just going to plug stuff into a formula. Is basically what I'm trying to say. In section 10.2, however, we will see how to draw rough graphs of solutions even when you have no explicit formula. That's what's called a slope field. We will also learn how to find numerical approximations to solutions. Numerical approximation to solutions is going to be something that actually only BC did. That's called Euler's method. But we're going to see something called separable variables, and we're going to see how we can use that to approximate solutions as well. Okay, so guys, on the next page, we're going to actually go through example 1. So I'm going to close my book here and go to my notes. But you guys can keep your book open on the side. Example 1. is what we're going to go over, and this is kind of like a way we can get, or a type of problem where we can get a general solution to a differential equation. So this is on the top of page 606. Okay, so I'm just going to write down some stuff that the problem gave us. So let me just double check in my book what was actually given to us. Yep, okay. So we're given this value for, or this function for y. We're given the function for y prime as well. I shouldn't say function. We're given the equation for y prime and the equation for y. Our goal is to show that every member of the family of functions, so every member of this family of functions, they say this family of functions because C, we don't know what C is right now. Okay, so we want to show that every member of that family is a solution of the differential equation of this. We want to show this is a solution to that, is what we're doing. Okay, so what we want to do is we want to basically take either side of the equation and set them equal to each other. All right, so first things first, this is our solution. Y equals 1 plus c e to the t divided by 1 minus c e to the t. Well, with that solution, what is y prime, right? Because we need to find what y prime is. And this brings you back to quotient rule. So we're finding a derivative of a fraction. We have to then do low d high minus high d low. So low is 1 minus c e to the t times the derivative of high. Derivative of 1 is 0. Derivative of c e to the t is just c e to the t. Minus, so low d high minus high, so 1 plus c e to the t. D low, which is negative c e to the t. All over low squared. Low d high minus high d low. I'm sure you guys really missed me saying that all the time. That's probably the part you hate most about missing school. It's just me constantly repeating stupid things over and over. I get it. So I'm doing this stream so I can keep bothering you. Okay, and then our goal right now is just to make this look simpler. If I were to try to set this equal to the other side of the equation, there's a lot going on. It can make things a little more complicated. So what I want to do is I want to simplify this the best I can. First thing is I would just distribute these c e to the t's. So I'm going to get y prime is equal to c e to the t minus c e to the t squared plus c e to the t plus c e to the t squared, all still divided by 1 minus c e to the t squared. Trying to make sure that these c's in parentheses aren't getting confused. So again, what I did was I just distributed c e to the t and negative c e to the t. Just distributed those out in the numerator. This turns into a plus because I have minus and negative. So that's why I get plus the quantity c e to the t squared. Okay, and then finally to simplify, just simplify the numerator. I get 2c e to the t because c e to the t plus c e to the t. And then negative c e t squared plus positive c e t squared gives me 0. Those will cancel. Okay, so that's what y prime is equal to. That's what I need y prime to be equal to. So with that being said, if that's what I need to get it equal to, I need to make sure that if this is y prime, then this value, 2ce to the t divided by 1 minus ce to the t squared, should be equal to 1/2 times y squared minus 1. This should be equal to that. Okay, that would make this statement true. That would mean that this y value, this solution we got, works. So next thing I need to do is I need to find 1/2 of y squared minus 1. Okay, plugging in values, that's going to be 1/2 times, well, y is 1 plus ce to the t divided by 1 minus ce to the t. So I got to take that entire value and square it, because that's y squared, then minus 1. So pretty ugly looking thing here, but okay, now I'm just going to take this step by step. So first step is I want to square this value. Reason being is that here's why I'm doing this, and this is what's going on in my head. So in my head, I'm thinking to myself, okay, I need to get this equal to that. That red circle, what's over here on the right side, has to end up being equal to whatever this is. So to do that, I see a couple things I need. I need this denominator. I need a common denominator. There's not two fractions, there's a single fraction. So I want to do whatever I can to get a common denominator. So to do that, I first need to square this fraction. That's got to be my first step. So what I'm left with is 1 plus ce to the t squared divided by 1 minus ce to the t squared minus 1, and then close your parentheses. Okay, so that's just squaring the numerator, squaring the denominator. Again, like I said, I want to get a common denominator. So their common denominator has to be 1 minus ce to the t squared, right? Because this is 1 over 1, so the common denominator has to be whatever this denominator ends up being. All right, and if that's the case, I'm left with still 1 plus ce to the t squared. But instead of minus 1, it's going to be minus 1 minus ce to the t squared. So to get a common denominator, remember, I got to multiply -1 times whatever my denominator is. So -1 times this is -1 minus ce to the t squared. All right, now I'm going to keep plugging away because I got this situation here. I can see that I'm getting close. Like it's starting to look a little familiar, but it's not exact. So I got to somehow write it so it's in exact form. So I still have that 1/2 out front. I'm going to actually go through and square these. So I'm going to get 1 squared is 1 plus 2 ce to the t plus ce to the t squared. So again, I'm foiling this in my head. I'm foiling 1 plus ce to the t squared in my head. Just so you guys know where I'm getting these numbers from. Minus, and then same thing, I'm going to FOIL this value in my head. So it's going to be 1 minus 2 ce to the t plus ce to the t squared. And this is all going to still be over 1 minus ce to the t squared. So again, foiling the two numerator values so I can simplify some things. Hopefully, that's the goal. All right, so I end up with, I'm going to try to give myself space so I don't have to switch pages. 1/2 times, simplifying the numerator. I have a 1. Okay, if I go down the line, I have a -1. 1 minus 1 is 0. So the 1's cancel. That works for me. I have 2 ce to the t minus -2 ce to the t. So the minus and negative will be plus. So I have 4 ce to the t in the numerator. And then ce to the t squared minus cet to the cet squared will be 0. So I have 4 cet divided by 1 minus cet squared. All right, and then 1/2 of this, you just take 4 divided by 2, and you get 2. So you get 2 CET divided by 1 minus CET squared. And what do you know? Look at what we have. Does that look familiar to you guys? Yeah, Mr. Harris? Yeah, it does. Good. It should look familiar. You guys will see that these red circles are equal. All right, so we just proved that y prime was in fact equal to 1/2 y squared minus 1. Because we found y prime and we found what 1/2 times y squared minus 1 was. That's what we're doing when we're finding general or verifying general solutions to differential equations. Thank you, Drake. That's how I imagine you all sounding. Yeah, Mr. Harris. Keep up the good work. Jaden, I know. Isn't it? It's crazy. It's crazy what math can do. All that work, and guess what? It's equal. It's a satisfying feeling. Very satisfying. Okay, so take that in real quick. Any questions you guys have while I take a bite of my breakfast? You let me know in the chat. What are you eating? Oh, Brandon, I'm eating a Cliff Bar. Let me show you. Crunchy peanut butter Cliff Bar. One of my favorites. I think my favorite's the mint, though. That's my go-to Cliff Bar, the mint. Like an 80s commercial. Are you ready for some super office breakfast cereal to fill your day full of energy? Yeah! That's true, Drake. I love those commercials, like the old Trix commercials that were like really obnoxious, or the Reese's Puffs. Remember the song for Reese's Puffs? It's like Reese's Puffs, Reese's Puffs. It was like peanut butter chocolate flavor. Love that stuff. I'm honestly not a big cereal guy though. I'm really not a big breakfast guy in general, but yeah, the mint is the best brand. I agree. Tricks are for kids? Man, tricks are for kids, we're all kids. Am I right? Okay, cool. Glad we had that conversation. That was productive. All right, so it doesn't look like anyone has any questions. Hopefully you had time to process this. A lot of algebra. Drake, I think you have a future in marketing. I think you know how to. You can really relate to kids. It seems like you have a gift. Love the enthusiasm. All right. So guys, I'm gonna look at the bottom of page 606. So after like their solutions to the problem we just did, I'm gonna read this last paragraph because this is kind of just good information to know. So it says, when applying differential equations, we are usually not as interested in finding a family of solutions, or the general solution, as we are in finding a solution that satisfies some additional requirement. In many physical problems, we need to find the particular solution that satisfies the conditions of the form y of t sub 0 equal y of 0. When we guys see that y of t sub 0 equals y sub 0, let me actually, might as well do this. Show you where I'm reading. So I'm reading right here. All right, so when you see something like this, y of t sub 0 equals y of 0, we call that a initial condition. They actually talk about that. I didn't even read the next sentence. Yeah, so this is called initial condition. We call this initial condition, meaning it's what's given to us initially. A lot of times you'll see a population at time 0 is equal to 500. That would be an initial condition. So when we start our experiment or start our, our simulation, the initial condition is the value you start at. And it's very, very important to have. So like a lot of times you'll see this like I mean there's millions of examples, but if you're trying to see, I mean population's just the one that always comes to mind. If you're trying to see populations of crabs on a beach in the next 5 years, well you first got to decide how many are here right now. Then you can create an equation to represent their growth and figure out the different things that are affecting the population, and then you can use that information to get a trend. But you need that initial value. Initial value kind of dictates everything, or that initial condition. Okay, so we call this an initial value problem. So in other words, an IVP is what you'll see a lot of times. An initial value problem, or an IVP. I think that's just a good little tidbit to know. So whenever you're given an initial value, it's called an initial value problem. I'm good with that last paragraph. We don't need to read that. Okay. Yeah, it is 10:32, Brandon. That's what happens when you have fun. Time flies. Oh, speaking of which, hey Brandon, when you get a chance at the end of class, hang out for a second because I gotta ask you something. So I assigned an assignment in College Board, and I want to make sure that you got it. And like, I don't know, I was told to assign you something, so I want to see if you got that. But that's beside the point. Next thing I want to talk about, let's actually look at an initial value problem. So this is one in the book. Let me flip this over. I lost a subscriber? Who unsubscribed? Man, it's unbelievable. That ruined my day. That's okay. You know what? I'll gain a subscriber. Every subscriber I lose, I'll gain 2. How about that? All right. So, example 2. This is in your book again. This is on page 606. So what they want you to do is based off of what we just did. So based off the work we did. Man, it's tough, Drake. Based off the work we did, I want to find the solution of the differential equation that satisfies the initial condition y of 0 equals 2. Okay, so in order to do that, we have to use the initial condition, right? I need to use the initial condition of 2 equals 1 plus CE. Instead of t, our t is now going to be our initial condition 0. And then 1 minus c of 0. So you'll see with these initial value problems, we're going to get more practice with them. But with the initial value problems, the goal is that we have to solve for c. So we have to get c first before anything else. All right, so solving this equation, actually, hold on. Well, actually, I'll do that. 2 equals 1 plus c e to 0. That's the same thing as 1 plus c because e to the 0 is 1. 1 minus c e to the 0 is the same thing as 1 minus c. So I get 2 times 1 minus c equals 1 plus c. 2 minus 2c equals 1 plus c. C ends up being 1/3. All right, so I just multiplied by the denominator. So I just had everything in the numerator, distributed the 2, and then just solved from there. Okay, so now that we have c, now we can actually find a solution. Okay, now this solution is going to be what y equals, except instead of c, we're just going to replace it with 1/3. Okay, so this is the answer you end up getting. So this just simplifies, this fraction simplifies to 3 plus e to the t and over 3 minus e to the t. But that's my solution to the initial value problem. So now any t that I choose, that's going to give me a solution. Or I shouldn't say give me a solution, it's going to give me a y value. Okay, not too bad. Again, that's called an initial value problem. Okay. Sorry, Brandon. Is that y? No, that's 1/3, Brandon. Sorry. I don't know how much that really helped, but 1/3. Okay, guys, I'm going to give us a practice problem. I'll let you guys do. Okay, so I want you guys to show that y equals x minus x to the negative first is a solution to x times y prime plus y equals 2x. So I'm going to give you guys a little bit of time. You guys can work on that. There's really no, we're just showing that it's a solution, so just in the chat, let me know when you're done. Again, guys, if you guys get finished, please put some in the chat so I can kind of gauge where we're at. Drake said, I think I did something wrong. Okay. Drake, my obviously, unfortunately, I can't see your work, but my recommendation would be to make sure that your signs are correct. So make sure that if you have like a minus something, put parentheses around what you're subtracting so you distribute that negative. That's always a good thing to check if you got the answer or something's not looking right. I mean, 2x does equal 2x, Drake. How you got there? Yeah, Drake, that should be okay. Yeah, Drake, you should be fine with that solution. Yeah, I'm just gonna do something a little bit different, but that's okay. Okay, guys, about one more minute, and I'm gonna get started. Okay, so let's take a look at this. So the question says to show that y equals x minus x to the negative first is a solution to xy prime plus y equals 2x. Okay, so if I want to show that this answer is a solution, I need to first, like, I'm missing pieces. Okay, x is fine. I'm okay with that because that's just that's, a variable I assign. It's an independent variable. All right, so I'm not worried about that. But I am worried about this. I know what y is in terms of x, right? I got that. I need to know what y prime is, though, in terms of x. So I have to solve for y prime. So my solution is y equals x minus x to the negative first. What's the derivative of that? And the derivative of that ends up being 1 plus 1 over x squared. That's what y prime is equal to. Now, if you guys saw the chat at all, Drake made a good point. So Drake did this a little bit differently, which is absolutely fine. I'm going to show you the way I did it, and then we'll see maybe if no one else did this way and everyone did it the way Drake approached it, however you wanted to do it. Regardless, though, you can see the answer is good. So my thought process was I'm just going to isolate y prime. So I'm going to get y prime on its own side. So very similar to like what we did, if you guys remember, with implicit differentiation. With implicit differentiation, we did this idea where we isolated y prime. So I'm going to get y prime by itself by dividing by x. So 2x minus y divided by x. Make sure you guys know those are y's, not 4's. Okay, so plugging in what I know, I could plug in 1 plus 1 minus x, or 1 plus 1 over x squared. I'm just going to leave it as y prime, just so I don't have to like see a bunch of fractions. Instead of 2x minus y, it's going to be 2x minus what y is, which is 2x minus x minus x to the negative first, all divided by x. Again, I want everything in terms of x, because as you can see, y prime needs to be equal to 1 plus 1 over x squared, not anything with y's in it. Okay, now from here, what I want to do is I want to start simplifying things. So a bunch of different ways you can go about doing this. The way I see it is distribute the negative. So 2x minus x gives me just x. 2x plus, or sorry, just a positive, I guess it would just be plus 1 over x. Instead of x to the negative first, I'm going to write 1 over x. And then all divided by x. Again, just distributing the negative. So this becomes a negative x plus x to the negative first. 2x minus x is x. X to the negative first is 1 over x. Okay, now I want to have a common denominator in the numerator. So it's going to become x squared plus 1 divided by x divided by x. Again, this numerator I made a common denominator. So instead of just x over 1, it's x over x, but that has changed to x squared over x. And then the 1 stays the same. I guess I'll just go below. Yeah. This is equal to x squared plus 1 divided by x squared. Because remember, if you take a fraction divided by a value, that's the same thing as taking that fraction and multiplying the denominator by the other number you're dividing by. Or you can think of it as multiplying by the reciprocal, where you're dividing by the fraction x over 1. So if you were to multiply by the reciprocal of x over 1, it's 1 over x, which gives you x squared in the denominator. However you want to look at that, it's algebra. And then simplifying this, x squared divided by x squared is just 1, and then plus 1 over x squared. And you guys will see that the two blue boxes are equal, so that's the end of your work. So that would be, you are correct, you verified it. Okay, so you guys can see the majority of it's just algebra, right? The only calculus you're really using is you're taking that initial derivative. So go ahead, guys, in the chat, let me know how you feel about that, if you're good. Good, good, I'm okay, good. Okay, cool. All right, so out of the next 9 minutes, I'll let you guys do your Khan Academy. So go ahead to Khan Academy. I'll be here to answer any questions you guys have. So I think now is a good time to transition to that. So take the next 8 minutes. If you don't want to stay, if you think you're confident, you want to do it another time, you're good to go. Have a great rest of your day. If you want to stick around for the next 8 minutes, by all means, stick around. Just so we're clear, like I just remember the Khan Academy has questions where it says, is something a solution? Right? We're doing the exact same thing we did today in class, except you're just seeing does it make it true? Like the answers we've gotten have been true. For Khan Academy, you just want to do the work, and if it ends up not being equally, then the answer is no, it's not a solution. So that's what you're looking for. Is the two sides of the equation equal or not? Whoa, I didn't know they had animal emojis. Cool. Now Drake doesn't have to move. He can just put the cow, and we all know what he's saying. Guys, if you're still here, I forgot to tell you, of course, right in the middle of me chewing, but the AP YouTube page came out with their first, their channel launched today. So they have lessons and stuff on there. So if you guys want to go on their YouTube page, that page I talked about yesterday, you guys can go there today, and they should have stuff up. So if you guys want to check that out, absolutely feel free to. Drake, because there is no one set way to solve, or no formula, does that mean I can solve it a different way and still be right? So the way I got 2x equals 2x, if I was to get 12x squared equals 12x squared, I could be right. Yeah, exactly, Drake. It doesn't matter how you prove that they're equal. You don't even need to simplify it if you don't have to. As long as they're in forms that are equivalent forms, then you prove that yes, it is a solution, right? Because then from that step on, anything you simplify is going to be the same. So if you can prove like a very basic form is equal to one side or the other, then you're good. That you can stop. Brandon, if you're still here, I sent out I assigned all of 8th period this assignment, but I said only you and Josh to do it, just to test the AP browser. I got a message from Mrs. Graves kind of telling me to assign you and Josh that problem. So it's obviously not a grade, not a problem. I just want to see if the browser works. So if you get the chance, Brandon, at some point, please go in and see if that works for you. I guess maybe you've been set up with it. I don't really know. So just want to fill you in on that and make sure you were aware of that. Yeah, Drake, that's exactly fine. That's perfectly fine. And then simplify the left side to get it 2x equals 2x. Sure. All good. Thank you, Brandon. Appreciate it. Yep, no problem, Drake. Mrs. Graves told me to install it yesterday. No problem. Okay, perfect, Brandon. Just, yeah, let me know how it goes. Good morning, Jaden. Yeah, so all my calculus kids, Algebra 2 is about to start. I hope you guys have a great rest of your day. Make sure if you have time, go ahead and check that YouTube page out. See what you think of it. Because I don't know, this is brand new, so I'm interested to get some feedback from you guys, see how it goes, how the videos are and everything. So I don't know what topics they're doing. I think they're doing differential equations, which is perfect timing. I'm pretty sure. So you guys can go check that out if you ever want some extra help. Okay. All right, Algebra 2. I need a topic. Let's hear it. What we got? Sports. Animals. I think sports is a little too small of a topic. I guess you could do like instruments in sports though, but animals. I like animals. Let's do animals. I gotta make sure I spelled it right. So the topic is animals. Okay, I'm good. A. One A. What else you got? It worked, Mr. Harris. I clicked submit, but it still says beginning College Board, but it said it was submitted when I was in Lifetime Browser. Okay, perfect, Brandon. Thanks for letting me know. If you don't mind, Brandon, maybe sending an email to Mrs. Graves and let her know the same thing. Sarah E. All right, good guess. My hint to you guys is this is my favorite animal, too. G. No G. See you, Brandon. Thank you. Mr. Harris's favorite animal. It's a bird. S. Good guess. There is an S. Get out of here, Brandon. It's your brother, Digidio. All right, I need some more letters, people. T. No T. L. There is an L. Aiden with the win. My favorite animal is a snow leopard. Well done, Aiden. Aiden Bath with the win there. Yep, my favorite animal is snow leopard, guys. They're awesome. The zoo got one at one point. It made me pretty happy. It's just a little guy too. You know, they're feel bad. I've been watching this Netflix documentary series. It's called Tiger King. Really interesting stuff. But I've seen a couple snow leopards on there, and it breaks my heart a little bit. These poor snow leopards. They're pretty awesome cats. No need for the applause. You're so humble, Aiden. So humble. Okay. Welcome, guys. Make sure you go ahead and hit that like. You know, that's your admission ticket. I won't start teaching until everyone hits the like. You know how that is. In about a minute, I'm going to start with class. So, guys, get your calendars up and open. And actually, while you're waiting, get ALEKS open as well. So we're going to talk about any questions you guys have from ALEKS. So get that up as well. Jaden, we're not going to be working from the book today, so I just want you guys to get ALEKS open. And then we're going to do some practice problems after ALEKS. So I'll talk about that. Actually, I'll just talk about it now. So good morning, every Algebra 2 student. Looks like I got 11 of you. So good morning. Hope you guys are having a good day so far. Here's the plan for today. So you guys can see on the calendar, I switched it up a little bit. No problem, Heaven. Thanks for coming. So again, I switched it up a little bit. We're doing 7.5 again today. So today is going to be a very relaxed day, guys. I'm giving you a little like midweek break. So I'm going to go over any ALEKS questions you have. So anyone who asks a question for their ALEKS assignment, I will go over it. We'll just walk through those, get some solutions for those. That's going to be the first part of class. The second part is I'm just going to pick practice problems. So I'm going to pick practice problems from 7.5, just random ones. And we're going to do them and get a ton of practice. And if no one needs any practice or you guys are good, then we can end the stream early, you know, whatever. We're going to kind of play it by ear. So I'm here to help you guys, but today is going to be a day to just soak in all 7.5 basically. So kind of recap everything, get like a more practice with everything. That's the plan for today. Very relaxed. Oh, and there's no homework tonight, so kind of a, it's not a day off, but it's a nice, more relaxed day for Algebra 2 today. Okay, so anyways, with that being said, let me know, guys, what ALEKS questions you have. So I have the ALEKS up and ready to go over anything you guys need. Okay, Sierra says number 3. Let's start there then. So we're going to be doing our ALEKS review. Number 3, so 1 through 4 was all the same question. So 1 through 4 was all the same type of question. So if you guys have any of the questions from 1 to 4, this is going to be the process you're going to do, what I'm about to do. Okay, so Sierra, and for everyone, I guess, I'm going to do the one that's on my screen. So let me show you guys. This is the problem that's on my screen. So this is the one I'm going to do. It's going to be exactly similar to the one you guys do. Okay, the only difference is maybe where the boxes are at, but we're going to be using the same properties, is the moral of the story. All right. So we have A, B, C here. So we have log base 4 of 9. I'm just going to write them down. So you guys can also write them down in your notebooks as I'm writing these down. So then this can help you as a little bit review, and you have it in your notes to look back on. B is going to be okay. So let me go back, down to my notebook here. These are the 3 questions we got. Okay, and the question ends up just being fill in the missing values. So you guys see I made these little boxes. That's what I'm trying to fill in. So I'm going to use a different pen. Okay, so the first one. These are properties of logarithms. That's the practice for the first 4. We want to practice with properties of logarithms. So the first property, I have, first of all the log bases are the same. That's a really good sign. All log bases are the same. I have a plus on the left side. So the idea is I want to set this side equal to the right side. In other words, I want to make both of them just one log base. So to do that, on the left side, I can combine this to log base 4 of 9 times 11 equals log base 4 of the box. Again, that's using my product property. So if you have the same log bases being added, you can combine what's inside of those logs and multiply them under one single one. Okay, the only way this is true is if 9 times 11 equals what's in the box. 9 times 11 is 99. So my answer would be 99 for that. Again, whatever's in here has to be equal to that to make this true. 9 times 11 gives me 99. Okay, number 2, same idea. So I have log base 9 of the box minus log base 9 of 11 equals log base 9 of 8 over 11. The left side, I don't have a product property because I don't have an addition, I have a subtraction. So instead of an addition, if there's a subtraction and they have the same log base, which in this case is 9, then I can write that as one single log. But instead of multiplication, I can do division. So that means I get log base 9 of the box divided by 11 is equal to log base 9 of 8 divided by 11. To make the inside the parentheses the same, the box then would have to be 8. Right? Because 8 over 11 is equal to 8 over 11. So my answer there would be in the blue, it would be 8. Again, using the quotient property. Okay, and the last property. So we have 3 properties: product, quotient, and the last one is the power property. So to use the power property here, I can rewrite this as log base 6 of 5 raised to the second power. So that's called the power property. I can take what is out in front of the log and throw it inside the log as an exponent. Because logs and exponents or exponentials are inverses. Which means that the inside of my box has to also be 5 squared, which is equal to 25. Right? The only way that this can be equal to this is if 5 squared is on the insides of the logs. So I get 25. All right, so go ahead in the chat, guys. Let me know if you have any questions on any of that. Sierra specifically, because you were the one that asked for that question. Thank you. Yeah, okay, no problem. Okay, and Jaden made a good point. He said, I know I went over this with Jaden yesterday during my office hour, so I know he's okay with it. But just for everyone else, I think this is a really good problem to go over. So you guys can see on my screen, I'm going to do this problem. This is going to be your very last problem, so number 12. Now, I don't know if you guys have seen, natural log at all, just because I've never taught Algebra 1 here. So I don't know if you guys ever saw a natural log or not. But that's what ln means. So that's an L. So these are ln x minus 7, ln 2. These are special kind of logarithms. So we've been seeing a lot of logs in log base 6, log base 10, log base 5, what have you. All right, natural log is what we call a special logarithm. It's a special logarithm because we can rewrite. So let me just do this in red. So note. Natural log is equal to log base e. So you guys might have noticed on your calculators you have the symbol e. E is not a letter. E is actually a number. So again, I'm not positive. I don't know if you guys have learned this at any point, but e is 2.719, something like that. So it's an actual value, just like pi is. Like pi is 3.14. E is just a symbol that represents a number. And it's a very special kind of number. Again, I don't know if that's pre-calc. We get into that. I'm not really sure. But regardless, here's a good introduction to you. So this is called a natural log. Again, it just is assumed that the natural log is equal to log base e. So it's just another type of log, which means that we do the exact same log rules or log properties as we would with any other log. Okay, so back to the problem. The problem asks us to solve for x. So I'm going to keep the left side how it is. Still natural log of x, just by itself chilling. The right side, though, I have a plus. I have the same base logs, so I have natural log for both of them, but I have a plus in between, I can use the product property. So instead of writing it as natural log of x minus 7 plus natural log of 2, I can write it as the natural log of x minus 7 times 2. Which means the natural log of x is equal to the natural log of 2x minus 14, if I distribute that 2. Okay, and the only way these are equal, because I have natural log on the same side, the only way that these are equal is if the insides of the natural logs are equal. So x has to be equal to 2x minus 14, which means negative x equals negative 14, which means x equals positive 14. And that would be your final answer for that. So again, natural log, it's just another type of log. You do the exact same properties, same rules. Nothing changes. Okay, so in the chat, let me know how you feel. Any questions you guys got, let me know. Still good? No problem, Michael. Thank you for coming. Michael, I know you're late. If you have any questions on ALEKS, please let me know. Anyone else have any questions on the ALEKS assignment? If you guys have a specific question you want me to solve, I can do it. So I'll give you a second to look through your assignment, make sure you're good, or if you have any questions. This is due at midnight, I believe. But don't quote me on that. I lied. It's due at 3:30. Yep, 3:30. It's due at 3:30. Sorry. Let me make that very clear. Not due at midnight. Due at 3:30. Okay. Number 8, said Haley. Perfect. Let's look at number 8. Okay. Turn this over. Haley, I'm just going to do the one that I have just because it's going to be difficult for you to type in your chat. But what we have here is it's a solve, so we're solving for x. So solve for x. And I'm given 8 plus log base 5 of negative 4x equal to 10. Michael, unfortunately, it's not that easy. I can't just change the time. I have to actually, I'd have to make an extension for every single person, so it's due at 3:30. But that's why you're here. I told you I go through every single question you guys have on this assignment, so we can get through all of them. 8. This is what I have. Hopefully, Haley, this is similar to your question. We're just solving for x. So first things first, I want to simplify the expression. So to do that, I have 8 and 10. Let's combine those. So I'm going to subtract 8 from both sides. So 10 minus 8 gives me 2. So I have log base 5 of negative 4x equals 2. Now we're using the definition of a logarithm to rewrite. So I'm going to make my log base the base of my exponential on the opposite side. All right, so negative 4x is equal to my base 5 squared. And now it's just algebra from here. So I have negative 4x equals 25. X is equal to negative 25 divided by 4. And that's it. That would be your answer. So hopefully, Haley, maybe that helps you with your problem. All right, any other questions you guys have, let me know in the chat. If you can type out a specific question I'll do. So when you added the 8 over with my problem, I end up with log base 3. Okay. Log base 3 of 2x equals 0. So Michael, that's what you end up with. Assuming that everything you did up to that point was good, Michael, you'll do the exact same thing. So instead of raising 5 to the second, it's going to be 3 to the 0. So that log base 3 becomes your base on the opposite side, and you raise it to whatever's on that side, that exponent. So you just take that 0, throw it up into the exponent. Okay, so now what you get is 2x equals 1, because 3 to the 0 is 1, and x equals 1/2 would be your final answer. So same exact process, you just have different numbers. Don't feel like confused if you get a 0, I guess, is my point. That's okay. Getting a 0 is fine. Yeah, no problem, Michael. Oops. I'm going to post real quick, guys, in our Google Classroom, just so everyone knows that ALEKS assignment's due today. Again, guys, keep typing if you have any questions on that assignment. Okay, so I'm not seeing anyone else typing anything in the chat. I guess here's my question for you guys. Would it be more beneficial to go over practice problems right now, or to give you guys time to do your ALEKS, and I'll just be here to help anyone who has questions as you go? Because I kind of looked to see how we were doing with this assignment. It looks like about a little over half has the assignment done. So let me know in the chat what you guys think, what benefits you the most. It looks like a lot of people who are in this chat are in progress, which means you guys are working on it right now. Michael says practice problems. Jaden says practice problems. Okay, that's 2 people, 2 good feedbacks. I'll wait to see if anyone else has a input. If not, I'll just do some practice problems. Haley agrees. Okay. Looks like that may be the answer then. So I'm going to give us some practice problems. Okay. Well, if you guys think that you don't need practice problems, by all means, you can start working on your ALEKS. But those of you who would like some, I'll do some practice problems right now. So give me a second. Let me pull some open. Okay. Page. Solving logs practice. That's what we'll title it. Solving logarithms practice. All right, your first question, guys, is going to be log base 4. Whoops. Hold on. Log base 4 of 48 minus log base 4 of n equals log base 4 of 6. So I want you guys to solve that. And I will give you, tell you what, I'll give you 2 minutes to do it. So at 11:33, I will be going over it, regardless of where you're at. So go ahead and get started. All right. Awesome job, guys. Okay, I'm sure Jaden's finishing up as well. There might be other people in here working. Those are the only ones I've been seeing in the chat. So, n equals 8. Yeah, perfect. So let's talk about it real quick, just to double check your work. So we look at this. What I notice on the left side is, first of all the log bases are the same, always a good sign. I notice on the left side I have a minus. Okay, that minus means I can use the quotient rule or quotient property. Quotient property says that log base 4 of 48 minus log base 4 of n can be rewritten as log base 4 of 48 divided by n. Okay, which means the only way this is true is if 48 divided by n equals 6, or 48 equals 6n, or 8 equals n. Okay, so setting the parentheses equal to one another, if I had parentheses on this one. So 48 divided by n equals 6, multiplied by n, 6n equals 48, divided by 6, n equals 8. Perfect. Well done, people. Let's go to number 2. So same thing, I want you to solve it. 3 log base 2 of x equals log base 2 of 8. Okay, one more minute. Okay, very good, guys. Again, all correct. So we want to use the power property to rewrite the left side. So it's log base 2 of x squared equal to log base 2 of 8, which means that, I'm sorry, this should be x cubed. Log base 2 of x cubed, take the 3, put it in the exponent, equal to log base 2 of 8, which means that x cubed equals 8. The only thing cubed that equals 8 is 2. So your answer would be x equals 2. Very, very good. Okay, let's try a trickier one. Let's give a little challenge problem here. Let me see. I'm just going to do it on the next page. So flip this over so I have plenty of room. So I have log base 10 of a plus log base 10 of a minus 6 is equal to 2. All right, guys, so I'll give you a little extra time to do this one. This one's going to take a little bit longer. Now you might need to use a calculator. If not, just put it into, just give me like a estimate. So just give me like a decimal place estimate of your answer. Hey Jared, I appreciate you showing up. No worries. Michael can fill you in if you guys are together. I don't know if you're together, but if Michael's with you, he can fill you in on what we did. I'll post the video so you can check out the first 40 minutes. No issues. I wrote the problem. You can see the problem on the paper there. We can get started right there if you're ready. And I'll be going through that in about maybe 5 minutes. Okay, about 2 more minutes, guys. Keep putting your answers there. We'll go through it. Okay. Yeah, no problem, guys. Like I said, this is kind of like a challenge problem. All right, so let's take a look at it. So hopefully, Jared, we're not really on a page. I'm just giving example problems. So hopefully you guys were able to get the starting point, which is what I really, really want to make sure. So the first thing you want to do is we want to rewrite this. So I have log base 10 of a times a minus 6 is equal to 2. That's got to be the first step we want to take. Okay, so hopefully you guys did that. Think to yourselves, is that what I did? And if you did, then good. Good start. You don't have to do this next. This doesn't have to be your next step, but I hate seeing that inside that parentheses like that. So I'm going to distribute that a. So I have log base 10 of a squared minus 6a equals 2. Now this might have been the first confusing step for you guys. If you got past this point, maybe this is where some of you messed up. I don't have the same log bases on either side, so I can't set this equal to 2. If this was log base 10 of 2, I could, but it's not. So instead, I use the definition of a logarithm, and I make 10 my new base of my exponential. So I get a squared minus 6a equals 10 squared, which means a squared minus 6a equals 100. And now I solve for a. Well, that's a quadratic, right? So I'm going to have to subtract 100 from either side. Okay. Oh, I'm sorry, Aiden. Was he the only one who thought that was a 9, or did you all think it was a 9? I apologize. Okay, so from here though, here's what I want you guys to tell me. Do you guys need me to do this a certain way? Do you want me to solve for a certain way? I guess is my question for you guys. Do you want me to solve for a in a certain way? Okay, so you guys thought it was an A. Good. Okay, Xbox. All right. So we can take a look at Xbox. You pick. Okay, the reason I ask is because of this. Well, let's just start with the Xbox. I like the way it's thinking. All right, so I'm going to make my Xbox. A times C gives me negative 100. That kind of stinks, but whatever. My B term is negative 6. So I need to find two numbers that multiply to negative 100 and add to negative 6. So let's start thinking. I have 10. 10 times 10 is 100. 10 minus 10 is 0. That doesn't work. I have 20. 20 times 5. That's going to give me negative 15. What else do I have? 100 maybe divided by 15? Nah, it doesn't work. 100 divided by 13? No. 100 divided by 12? No. And so on. Okay, and I can keep trying to value as much as I can. I'm not going to find anything that makes this work. So I'm crossing out my Xbox. I'm Xing out my Xbox. That strategy is not going to work, unfortunately. So I have to use a different strategy. Now you could use quadratic formula, but just for the sake of saving some time, here's what I'm going to do. I'm going to go to Desmos, and I'm just going to graph this sucker. So yeah, you should just be seeing my face right now. So I'm going to graph it. I have to acknowledge I'm not saying you have to do it a certain way. So if I have the opportunity, I might as well graph it. And instead of a, I'm going to use x. So x squared minus 6x minus 100. Okay, and I'm going to leave it here for a second in the chat. What am I looking for? What am I looking for to solve for a? So I have the graph of what I got. I want to figure out, though, what am I looking for to actually solve for A? What's another name for these solutions, I guess, would be another type of question I could be asking you. The roots. Okay, so zeros are, yeah, very good, guys. Sierra, vertex, we're not looking for the vertex. The vertex is useful to us, but in this situation, remember, we set this equal to 0. So we're looking for, like Aiden and Haley said, the roots or the zeros or the x-intercepts. So these are the points we're looking for. All right, so A equals negative 7.44. A equals 13.44. The question is, are they both answers? Are they both roots to this problem? Or is only one of them, or is neither of them? Okay, so my question then is, which one of these works? Well, if I look back, guys, remember, what we're looking for is if your answer gives a log if your answer makes an original log negative, meaning inside of the logarithm you have a negative value, that's going to be extraneous. That has no solution because it's undefined. So if I plug in negative 7.44, if I take this and I plug it back into the original equation, I'm going to get log base 10 of negative 7.44. That doesn't exist. That's undefined. So this isn't going to work. It's going to give us an extraneous solution. So right off the bat, I can eliminate that as one of my solutions. If I plug in 13.44, I get log base 10 of 13.44 plus log base 10 of 13.44 minus 6, which is 7.44. That's good. Equals 2. That works. Those are all positive values. Oh, I'm so sorry. It's been on my face the whole time. Sorry, guys. Here's what I was talking about. I gotta stop doing that. So plugging in A equals negative 7.44 into the original, it's going to give me a negative value here, which is no good. That means it's undefined. So if you put that in your calculator, you would get it wouldn't give you a value. So that's kind of your hint. If you have a calculator, just plug in your calculator real quick. If you see that it says error or undefined, then not good. So get rid of negative 7.44. You plug in 13.4, bueno. We're doing good. All right. Any questions for me, guys? I think I'm good then. Perfect. That is the goal. All right. Do you guys want another type of question, or you want to do one that was like this one, or are you guys good for today? Good for the day. Okay, Michael. If you'd like to do one more, that's fine with me. Okay, Aiden. Let's do one more. So this will be the last one, guys. You're good to go. If not, if you do take off, have a great rest of your day. We'll see you tomorrow. We'll do one more if you guys would like. This is going to be a similar type of problem. Aiden, these are going to be A's. we'll end the class on this problem right here. Log base 10 of a plus log base 10 of a plus 21 equals 2. See you, Sierra. Have a great day. This will be the problem we end on, guys. So I'll give you about 4 minutes, and then we'll go through it, and we will be good. If you guys want to put your answers in the chat once you get them as well, that works. All right, guys. I'm going to go over this one. So if any of you are still in here. Oh, good time. Okay. So Jared did get an answer. All right, good job, Jared. That is correct. So let's just take a look real quick then. Log base 10 of a plus log base 10 of a plus 21, I can combine into a single log. Log base 10 of a times a plus 21 equals 2, which means that log base 10 of a squared plus 21a is equal to 2, which means a squared plus 21a is equal to 10 squared. Okay, so I know I went really quickly. First, we use the product property. I simplified on the inside to get a squared plus 21a equal to 2. I then use the definition of a log to do 10 squared is equal to a squared plus 21a, which means a squared plus 21a minus 100 is equal to 0. That's my quadratic equation I need to find. All right, and then you guys can use whatever method you wanted to use. I am going to, let me see what I want to use. I'm just going to use Desmos again. Okay, and you should get A equals 4 and A equals negative 25. You plug those back in, A equals negative 25 will give you extraneous solutions, so your only answer is A equals 4. All right, guys? So if you have any questions on that problem, let me know. If not, you are good to go. No homework tonight unless you didn't finish ALEKS. Then you have to do ALEKS. But I hope you guys have a great rest of your day. I will see you all tomorrow, and I'll be here for office hours if you have any extra questions. Yep, you too, Aiden. Appreciate it. I'll see you guys all. Have a great day.